Okay, so we're asked to find the surface area of the part of the paraboloid z equals 1 minus x squared minus y squared that lies above the plane z equals -2. So to sketch out what this would look like, we have yxz plane opening downwards because of our negative coefficients and shifted up by 1. And then if you have the plane at -2 for z, we could see that it kind of intersects at some circle. Now, I'm not the best at graphing, but we could see that's where it kind of intersects. And we could find the intersection analytically by observing that z is equal to z, or z is a function of x and y, so when you set them equal to each other, and then with some algebra, we get to x squared plus y squared equals 3. So a circle with radius square root 3, right? And then, well, the surface area, what is that? How do you compute it? So there's a formula. It's derived by making infinitesimally small tangent planes, and those tangent planes are calculated using really small differentials, right? You're infinitely small things, so you're working differentials, and you take the cross product, will give you the area of some plane. Or the area, yeah, exactly. So whenever you do compute it, you'll arrive at the following integral. So it's 1 plus the partial derivative of x squared plus the partial derivative of y squared. So what is our function f? It's going to be our upper bounding function, which in our case is 1 minus x squared minus y squared. So our partial derivative with respect to x comes -2x. Partial derivative with respect to y comes -2y. Plugging into formula.
So just remember, are you gonna be circle? So we just remember that if it's
right. So f of x is -2x. -2x squared is positive 4x squared. Same thing for y with that symmetry. And from here we could factor out a 4, and the reason for that is because we're going to be converting into a polar system. Right, so, or sorry, I'm getting ahead of myself. Now, if we're in polar, our region D is the circle projected onto the xy plane. And what is that circle? That's the intersection, right? Because we're trying to find if we have some region R being that, or not some region, if we have some volume R, then our region D would be that sort of disk projected up to the xy plane. So it's a circle with a radius of 3, like we calculated earlier. So we could say our D is order 2 r theta, such that R ranges from 0 to the square root of 3, and theta ranges from 0 to 2 pi. So D ranges from 0 to 2 pi, theta ranges from 0 to 2 pi, r ranges from 0 to the square root of 3, and then it's going to be the square root of 1 plus 4r squared. Where's the r squared coming from? In a polar space, if we define x to be r cosine theta and y to be r sine of theta, that x squared plus y squared, squaring both sides, will give us 1 by the Pythagorean identity. And then we also need to scale by r because of the Jacobian, if you're interested in that. I'll do a video later, maybe, of what a Jacobian is. Actually, no, I have covered that. Look at unit, or the change of variables. That's where the Jacobian is explored. But anyway, dr, and then d theta. So observing that this integral has no terms that will generate theta, basically our integrand is a constant, we can just say that 0 to 2 pi of d theta will be just 2 pi when we use the second fundamental theorem of calculus. We get to that result. But in our integral, we need to use some sort of u substitution. So if we observe that u defined as r plus 1 plus 4r squared, giving du to be 8r dr, and then scaling du by 8 gives r dr, right? Just dividing both sides by 8. R dr is du over 8, so we could say du over 8, we could factor out that 8, and then we have u to the 1/2, or the square root of u, right? Because this is what we define u to be. And now our bounds change, so now we're ranging from 1, right? So when r is 0, u is 1. When r is square root 3, u is 13. Simplifying here, and then just working through like a calculus 1 problem from here. And that should be our result. Yeah, so the reason that when you evaluate 13 given 3 over 2, that's saying 13 to the third square root. The square root of 13 cubed. Well, 13 cubed is 13 squared times 13. That's a perfect square. So we have 13 square root of 13. So yeah, that's if you're wondering about that. And then 1 is trivial. And that's our solution. That is the surface area of this sort of paraboloid above our plane.